Okay, for question 1 on problem set number 8, I've actually written out the solution for you here because I just got started and kept going. So I'll just go back and explain what I did here, okay? So if we want to solve for dq dt, which is the change in demand over time, then first thing we're going to do is solve our equation in terms of q. And since we're differentiating with respect to t, I'm going to have dq dt, and then I also need to differentiate the other variable p and have a dp dt included as part of that also. And so what I did here is I used the quotient rule. Another way to do it would be to write this as 3,000 e to the negative 0.02 p, and then you could just use the e to the x rule, okay? So using the quotient rule, I ended up with a 0 for the u prime v part, and then minus the v prime u is what this part is. So this is v prime u because the u prime v was 0. And so what I've done here is taken the derivative of e to the 0.02p, which is still e to the 0.02p. I've multiplied by the top, which is u, and then I've multiplied by the chain rule part, which is the derivative of the bracket. And so 0.02 dp dt is what I get there. So now I'm going to fill in the values that they gave me. They said that p starts at $10 and that p is going up by 50 cents per year. So that's why I entered those values in the next line of the solution. And so everything is filled in, which means I can put it in a calculator and get an answer. The answer I got is negative 366.42 globes per year. So that means that we would be selling that many fewer globes, probably round off to negative 366 because you can only have whole numbers of globes, but you would be losing your market for that many per year if you were doing a price increase of 50 cents a year. All right, so for question 2, I just wrote out the formulas that we were given, and we have S, and then we have a T formula. So we're going to take the S. All right, and so if we are being asked for the change, okay, they're giving us dt, change in temperature over time. The radius is decreasing. They're giving us that rate. How quickly is the height changing with respect to time? Good. Okay. So what we're going to do is we're going to do implicit differentiation again. We're going to do dt over d little t for time, equals 30 is going to have a derivative of 0. And then we're going to put in, this one's going to be product rule, okay, because we have two different variables there. So we're going to do 2 pi for the derivative of 2 pi r times h plus dh dt. Oh, that was the derivative of r, wasn't it? So that's times dr dt. Okay, plus 2 pi r times dh dt plus 4 pi r dr dt. And that looks complicated, but it's not, because we have dr dt, we have dt dt, and we're only being asked for dh dt. So in the next step, we're just going to fill everything in. Just make sure I can still see all of the numbers here. I might need my glasses. Okay, so dt is increasing at 1 degree per hour, and h okay, they're not giving us h. 2 pi times h, and then times dr dt, which is decreasing 2 centimeters per hour, plus 2 pi times r times dh dt, plus 4 pi r times minus 2 again. So, all right, so we don't have r, and we don't have h. And there's no relationship between them described in the question. Okay, this one's just got me a little confused because we can go so far, but we can't solve it because we're missing too many variables here. We can solve for dH/dt in terms of the other variables, but we can't actually get the dH/dt value unless I'm missing something here. So I'm going to ask you again, like I did on the one yesterday, if you have a solution for this, or if there's other information that I'm not seeing here that gives me R and H in terms of the starting values, then could you send it to me so that I can finish this one off correctly for you, okay? Oh dear. Okay, so the last problem set here, each of these questions, oh, I remember this one. Okay, each of these questions is asking us to find the absolute max or min, or both, of these functions. And so what that means, I think we've talked about this before. Let's say that we're looking at question 1, and I'm not sure exactly what this graph would look like, but we want to look between -1 and 4 to look at only a portion of this graph, not the whole thing. And it's a cubic function, so I don't know what it's going to look like. Let's see, it looks something like this, okay? So if you look just in this frame between -1 and +4, they're asking us what's the absolute highest value of y and what's the absolute lowest value of y. So even though it looks like maybe there's a maximum as a turning point or a critical point up here, in this field of like between -1 to 4, this is the highest point. And then here we have a minimum, and there doesn't seem to be a lower point than that in between -1 and 4. So what we have to do is, first of all, find the first derivative. So we would have f prime of x equal to 3x squared minus 12x plus 9. We're going to set that derivative equal to 0. I'm going to divide everything by 3 because that's a common factor here. And then I'm going to try to solve it by factoring. So if I have x minus 3, x minus 1 for my factors, then x equals 3 and x equals 1. Okay, so I got those factors from breaking down 3 into two numbers that multiply to make 3, and only 3 and 1 would work there. And if they also have to add up to -4, if I make them -3 and -1, then they also do that, which makes them the factors we're looking for. So I know now that at x equals 1 and x equals 3, I have a max or a min at those points, okay? So these are max or min, and we don't know yet which ones they are. And so what we're going to do now is we're going to make a chart, and we want the highest y value and the lowest y value in this range. So for our x values, -1 is the beginning one. Then we got x equals 1 when we solved it. Then we got x equals 3 when we solved it. And then 4 is the right-hand limit of our frame here. So all I'm going to do is just work out the y value, or the f of x value, right? So put it back into the original equation, -1 cubed minus 6 times -1 squared plus 9 times -1 plus 2. And so in that case, I get 1 minus 6, and that's -5, then minus 9, and so that's -14, and then plus 2, so that's -12. Now I'm going to do that for each value here. I'm going to put the 1 in next, and I'm going to get 1 minus 6 plus 9 plus 2, and that's going to give me 6. Then I'm going to do it with 3. I'm going to get 27 minus 54 plus 27 plus 2, and that's going to be 2. And then I'm going to do it with 4, and I'm going to get 64 minus 96 plus 36 plus 2, and that's equal to, let me see, 6. Okay. And so when I look at my y values here, I've got a lowest value of -12, and that occurs when x equals -1. So I have the point -1, -12. And the highest value I have seems to be 6 here and here. So I have 1, 3, and, 1, 6. And 4, 6. Okay, so this is going to be our absolute lowest point. And these are absolute maximum points in that range between -1 and 4. Okay, so that's how we do all of these questions. For the next one, your derivative, I'll just give you the derivative there to get started. It's going to be 1 over x squared plus x plus 1, and then the chain rule part of that is going to be, plus 1, sorry. The chain rule part of that is going to be 2x plus 1, because that's from the derivative of what's inside the bracket, okay? And so what we're going to do there again is set this equal to 0. And so that's just going to leave you with the equation 2x plus 1 equals 0. You're going to get one answer, which is -1/2 here. And then you're also going to have to test -1 and 1. So whatever x value gives you the lowest y and whatever x value gives you the highest y, those are your absolute max and mins in this space, in this frame, okay? And then for the third one, I'll help you out with your derivative on that one. Let me just make this a bit smaller. There we go. And so for question 3, when you find your first derivative, and you're going to take that and set it equal to 0, you're going to get -e to the -x. Then you're going to get plus e to the 2x times -2. Okay, and so, e to the -2x times -2. So if you set that equal to 0, then the easiest way to do that would be to factor out an e to the -x, And then that's going to give you a negative 1 minus 2e to the negative x. And then you're going to set that equal to 0. E to the negative x can't be equal to 0. So that means that negative 2e to the negative x must be equal to minus 1 in order to make that bracket equal to 0. And that means e to the negative x equals 1 over 2, e to the negative x. Okay, so 1 over e to the x equals 1 over 2, which means e to the x equals 2. And then you would solve that on your calculator to solve for the exponent x that gives us 2 when we put it on the base e, and that's going to be slightly less than 1. Now you're going to test between 0 and 1, and our value here for our x is going to be between 0 and 1, so you're going to test 0, you're going to test this value, and then you're going to test 1, and you're going to look for your absolute max and your absolute min.